Dear students, in this video let us work out some problems related to LPP equation. So x plus y is equal to, we have converted the inequality, x plus y is equal to 4 and 2x plus y is equal to, now x plus y, x is equal to 4, y is equal to 4, x is equal to 4, y is equal to 4. Similarly, second equation, x is equal to 3, y is equal to 6. Okay, fine. So that we got, okay, now both are x plus y is equal to or lesser than or equal to 4. So it lies, the feasible region should lie below this line, this is the line, it should lie below this line. The other one is also 2x plus y is equal to lesser than or equal to 6. So there also it should lie, the feasible region should lie below this line, okay. But you can't show the feasible region here, because for this line it becomes above this line. So similarly here you can't show the feasible region, because for this line, that is the second equation, for that this region becomes above the line. So therefore feasible region lies below these two lines. This is very important. This is the two lines, and for both the lines the feasible region should satisfy both the lines. So in this region will satisfy both the lines. For both the lines, this particular part lies below below these lines. Okay, fine. So now next step is you identify the corner points. We have identified the corner point A, B, C and O here. Okay, fine. Now the feasible region is identified and is shaded as shown in the graph. Now go to the next step, step number 4. A, B, C, O are the corner points of feasible region whose coordinates are noted in accordance the objective function is evaluated. Okay, corner points: A 04, B 22, C 30 and O 00. So here the question is like, how do you get B? So here B, you have to solve those two equations, like x plus y is equal to 6 and the second one is 2x plus y is equal to 6. Okay, now when you solve these two equations simultaneously, you get the values of x and y, and the values of x and y to each. Okay, and since we have already solved this kind of equations in the regression, I'm not going to explain them in detail here. So if you solve these two equations simultaneously, you get the values of B here 2 2. Okay, fine. Now you substitute the values, corner points, to the maximization function. Z is equal to 3x plus 10y. So in the first one, corner point A, x is equal to 0, y is equal to 4. So the final value is z value 40. Second one, x is equal to 2, y also 2. So z is equal to 26. Then in the third one, C, x is equal to 3, y is equal to 0. So therefore the point z is equal to 9. Last one, x is also 0, y is also 0. So therefore z is equal to 0. When you look into these 4 points A, B, C, O, the maximum value we get it for point A, where the value is, z value is 40. So this is the maximum value and this is the unique one, because no other corner points will give you this value. So maximum z is equal to 40, which is unique, occurs only at corner point A. Now thus the given LPP has a unique optimal solution. The solution is x is equal to 0, y is equal to 4 and the optimal value of z is 40. Now let us move on to discuss one more problem. Graphically solve the following LPP. Maximization: z is equal to 100x plus 20y, subject to x plus y is greater than or equal to 20 and 2x plus 5y is equal to lesser than or equal to 80. See, the first constraint more than or equal to 20, second one is lesser than or equal to 80. So accordingly you have to be very careful this inequalities while shading or while finding out the feasible region. So x and y, they are greater than or equal to 0. Now integers. Okay, first step, convert inequalities into equalities. So x plus 2y is equal to 20. So x is 0, y is equal to 10. 20 divided by 2. Here 20 divided by 2 is equal to 10. Second one, y is equal to 0, then x becomes 20. So the points are like first one is 0, 10, and second one is 20, 0. X is 0, y is 10, and second one x 20, y 0. Second equation, 2x plus 5y is equal to 80. So x is equal to 0. If you assume x as 0, y is equal to 80 divided by 5, which is 16. Similarly, if you assume y as 0, x is equal to 80 divided by 2, which is 40. So corner points are 0, 16, x is 0, y 16, and x is 40, y 0. Then x is equal to 0 and y is equal to 0. Now choose the suitable scale and plot them in a graph sheet. So this is the graph sheet. Look at here. First equation, x plus 2y is equal to 20, and second one is 2x plus 5y is equal to 80. Now if you look into the inequality part, x plus 2y is greater than or equal to 20. So therefore the feasible region should lie above this line, this part. Okay, but the other one, 2x plus 5y, is lesser than or equal to 80. So therefore the feasible region should lie below this line. So now this is satisfied. So here feasible region lies between these two lines. So now you identify the corner points. So feasible region is identified and shaded. So you can put the corner points. So first one, A, B, C, D. Okay, now the corner values are like for A, 0 and x is equal to 20, y is equal to 0. For B, x is equal to 40, y is equal to 0. For C, x is equal to 0, y is equal to 16, and for D, x is equal to 0, y is equal to 10. Okay, look at here and you can find out the z value here. So first one, z is equal to x 20 and y 0, so the value is 2000. Second one, x 40, y 0, the value is 4000. Second one, x 0, y 16, the value is 320. Last D, x is equal to 0, y is equal to 10, the value is 200. So now among these 4 points, point B gives you the maximum value, optimal value. So therefore point Z is the optimal solution. It's has a optimal solution, unique optimal solution. Okay, so thus the LPP has a unique optimal solution. The solution is x is equal to 40, y is equal to 0, and the optimal value of Z is equal to 4000. Problem number 3. Graphically solve the following LPP. Maximization of 2000x plus 1000y subject to x plus y lesser than or equal to 400. Second one, 8x plus 5y lesser than or equal to 2600, and x and y are greater than or equal to 0. Now, so the first step, so convert them into equalities. So find out x and y. X is equal to 0 and y is equal to 400 if you assume x as 0. In the second case, if you assume y as 0, x is equal to 400. So the corner points, the points are 0, 4000, 400 and y 400 and 0. Then for the second one, so if you assume x as 0, then 2600 divided by 5 is equal to 520, which is y. Similarly, if you assume y as 0, x is equal to 2600 divided by 8, which is equal to 325. The points are 0, 16 and 0, 520 and next one is 325 and 325, 0. So let x and y is equal to. Now choosing a suitable scale, put them on a graph. So now this is the graph. So here Okay, the first one, x plus y is equal to lesser than or equal to 400, it should lie this part. Second one, 8x plus 5y is lesser than or equal to 2600, again it should lie below this line, but this particular part will satisfy both the lines, so therefore the feasible region is here. Okay, now x is equal to 1 cm, in the x-axis 1 centimeter is equal to 100 points or units. Similarly, y-axis 1 centimeter is equal to 100 units. This is very important here. Okay, the first one, x is equal to 400 and y also 400. So these are the points connected here by drawing a straight line. Then second one, x is equal to 325, y is equal to 525. Okay, now they are connected, so you get the straight line. So we got the feasible region. Now identify the corner points A, B, C, D. Okay, to find out the values of B, of course you have to solve these two equations, x plus 5 400, 8x plus 5y is equal to 2600. These two equations are supposed to be solved simultaneously so that you get the values, okay, of B. Now we'll go for that. So corner points, first one 325 0, second one 200 and 200, next one is 0 and 400, last one is 0 and 0. So when you substitute the values into the z function or maximization function, you get the values like this. The first one 3.5 and 0, so 6,50,000, second one 6 lakh, next one is 4 lakh, last one is 0. So only one point will give you the maximum value, which is point A. So therefore this problem 2 has a unique optimal solution. Okay, so the LPP has a unique solution, and the solution is x is equal to 325, y is equal to 0, and the optimal value is 6,50,000.